Alright, today we're going to be testing out Battery Hookup's brand new fused nickel strip. I've got a cat here now. Hey, stay over there. Come on, dude. Me and Horace are going to be testing out Battery Hookup's new fused nickel strip. Quit. It's not that new, it's been out for just a little bit of time. Okay, your tail is hitting everything. Tail is literally knocking everything over. Alright, I'm gonna try this again. Boom! Alright, I'm Average Joe. Yes, my name is actually Joe. I'm just an average person doing average things. That's where the name comes from. Just like I said a second ago, we're gonna be testing out Battery Hookup's new, it's not new, I don't know why I want to call it new, but new to me, fused nickel strip. Now this isn't going to be a sales pitch video or anything like that. A subscriber by the name of Rich Palmisano sent this to me to test it out. Sorry it took so long, I was a little busy at work. So a big shout out to Rich for sending this out. Alright, like I said, this isn't a sales pitch video or anything like that. However, if for some reason you find you can't live without the nickel strip or pretty much anything else Battery Hookup offers, make sure you click the links down below and use the discount code BOOM for 10% off of anything that you order. Anytime. Alright, at this current time, Battery Hookup only offers just a few options. They're sold out all the other options, basically. So I'm going to use this 3P for the example. So over here on the right, they're going to tell you everything about the nickel, and pretty much what I'm interested in is the specs. It basically says that the fuse is rated for 3 amps continuous, and it pops at 8 amps. The nickel in between all the fuses and whatnot can carry 10 amps, or the nickel can handle 10 amps per row on a 1 to 4 cell wide pack. So what that means, or what he recommends, is after spot welding all the nickel fuses to your cells, you connect a bus bar down the long side of the pack, which will allow 10 amps per row, and that also pretty much distributes the load equally for those cells. If that doesn't work for you or your design, then you could probably just add the normal bus bars we make for Powerwalls, and you would probably get actually better distribution between the cells. Also, this fused nickel strip is designed to pop in the event that there's an internal short, which means a direct line to ground through the cell, and all the other cells in the pack will send their energy or current to the bed cell and pop that individual fuse. So, having said that, keep that in mind whenever I'm testing this fuse, because, well, some of the tests are not that. Okay, so keep that in mind. Alright, so you're asking, what kind of tests are we gonna do? Well, the first test is gonna be pretty much like all of my old fuse videos. We're gonna throw it on the old fuse tester and pretty much see where it pops at. It says 8 amps. Well, I want to see how close to 8 amps it actually is with my tester. Now keep in mind, mine is a DIY tester, if you will, so it's going to be close. It's not going to be 100% accurate, but it should be close enough. And then we'll probably do like a second one for consistency. During these tests, I'm also going to have a red meter, which you'll see later on, and everything on that meter is going to be a voltage drop in millivolts, unless we go like above 1,000 millivolts, because 1,000 is 1 volt, or if it goes higher than that, then you get the idea. And then we're going to do some additional tests, and most of these ideas were from my Patreons, one of which I'm actually really excited about because I get to use my new Seek thermal camera that I've had for like a year and a half, and I've only managed to look at my cat. One test is not really going to be a test, it's going to be more of a visual, and I'm just going to show you the glow of the fuse whenever it's getting hot. One test, I'm going to try to simulate how he actually wants you to hook it up with a bus bar on one side. I'm not going to have a bus bar, but I'm going to hook up power on one side of a strip, and the voltage is going to have to go down the strip, and I'm going to connect at the fuse, and we're going to see how much voltage drop is across that nickel strip. I'm going to do a dead short test. Again, this is going to be with a power supply, and then I'm going to do a simulated fuse pop with some heat shrink. I almost said shrink and wrap at the same time. Heat shrink right over the pack. And a big shout out to Kieth for sending out his super fast, excellently packed package You know what I mean. He sent some big heat shrink. He sent his big heat shrink right over. Oh, is that what they're calling it these days? And finally, we're gonna attempt to replace a bad cell in the middle of a pack. Now this pack that I'm gonna be using, I'm not using real cells. Basically, I spent all freaking day outside in the cold, cutting off the tops of cells so I could have something inside to simulate the top of a battery pack. Basically, because I didn't want to short out a bunch of cells inside my house. It's too cold out to do all that, even though I spent all day outside in the cold, you know, cutting open a bunch of batteries. All right, so having said all that, I'm going to attempt to make this video not boring, and I'm going to try to make it as fast as I can, which we all know is a big lie. So sit down, get comfortable, grab your favorite cat, let's open this package up and see what we got and get the test started. And it comes on a little roll. So right now we got 2 feet and this is 4P. That looks pretty nice, actually. I'm pretty impressed. Could you imagine this being... Let me do something real quick, sorry. Roll it back up. Could you imagine... We're gonna try this out real quick and see if it works, because I just want to test a few at a time. Alright, let me get the fuse tester set up real quick. Like, what's that? What's that doing there? Alright, well apparently I forgot I robbed some parts from this a while back. I'm gonna have to fix it real quick. Alright, this is gonna be test number 1. We're using the 3.3 volt rail, and I'm gonna run it down the resistance wire to find out exactly where it pops. And I'll try to make it as smooth as I can. Kjær. And it looks like with the resistance wire that I'm using now, the lowest I can start off with is 2 amps. So at 2 amps, we have a voltage drop of 42 millivolts. Here we go. And from my view, it kind of looked like it went just a little over 10 amps. Alright, this is going to be test number 2. We're set up the exact same way on the 3.3 volt rail, and we're just going to run it down the resistance wire to see where it pops. Kjær. Alright, from my view, it looked like it was around 10 amps, but of course I'll have to look at the video to make sure. Alright, this is going to be test number 3, and this is going to include the thermal camera. We're set up the same way on the 3.3 volt rail. The only thing different I'm going to do this time is instead of doing 2 amps all the way up until it pops, I'm going to start off at 3 amps and hold it for roughly 30 seconds. And then I'm going to go to 4 amps, hold it for 30 seconds, and continue all the way up until it pops. Kjær. Not much happening here, going to 4 amps. Alright, again, not a lot happening here, gonna go to 5 amps. Alright, going to 6 amps. It's a little higher than 6 amps. It looks like it's settling down a little bit. Alright, going to 7 amps. It starts off at 7 amps and then it kind of backs down a little bit, and that's just because the fuse is glowing red. Alright, I'm gonna try 8 amps. Goes up to 8 and then it's backed off to 7 amps now. Alright, gonna go up a little bit higher here. Went up to 10, we kind of backed off to 9 amps, and it popped. Alright, next test is going to be without the lights, and I'll turn those off in just a second. This next test is basically just a visual of the fuse glowing. That's all it's going to be, is just a visual. And I'm also going to throw the thermal camera on there as well. And with this test, I'm going to start off at 5 amps. Let me turn off the light real quick and we'll get started. Alright, here we go. Contact. Alright, I'm going to move up to 6 amps. Alright, I'm going to move up to 7 amps. Alright, that was 1 minute of time, moving up to 8 amps. Alright, that was 1 minute, gonna go up just a little bit higher, try to get 9 amps. The amp meter shows we've backed off to 8 amps. Alright, that was 1 minute of time. Gonna go up a little bit higher to try to get 9 amps. I'm drawing 9 amps. And it's popped. Alright, next test is going to be set up like this, and this is the best way that I can simulate how Tom recommends hooking it up, where you would have the rest of your cells going this way, and he recommends to hook it up along this edge. That way you get the maximum amperage across these 4 cells. If you had a 5P, then you would typically hook up your bus bar along this edge right up here. Hopefully I'm explaining this correctly. So the best way I can represent that is just hooking up my connection right here, so the voltage and amperage can travel through the nickel strip over to the fuse, and I'm just going to show the voltage drop from there. Alright, this test is going to be set up just like before. We're using the 3.3 volt rail, and I'm also going to just jump to the 2 amp, 3 amp, 4 amp, and so on until it pops. Alrighty, here we go. Contact. Alright, going to 3 amps. Alright, going to 4 amps. Alright, going to 5 amps. From here on out, as soon as I start going higher, the amp meter is going to back off just a little bit. So I'm going to attempt to get 6 amps. Alright, I'm going to go back up to, I guess, 7 amps if I can. Alright, gonna go up to 8 amps. Alright, gonna go up to 9 amps. And it should pop here anytime. We're kind of just above 8 amps now. And once I go past 2000, this is going to read 0. So I'm going to go ahead and just pop it here. There we go. Alright, this next test is pretty much just going to be a dead short test. Now keep in mind my power supply can only put out 28 amps on the 3.3 volt rail, so it could take like a second or two to pop that, but that's pretty much what I'm going to do. And I'm going to short it out on the back side of the shunt, so at least it does show up on the meter. Alright, here we go. Contact. Alright, next thing we're going to do is spot weld this to some fake cells, and then we're going to put some heat shrink over that and then individually pop the fuses just to see how it reacts to the heat shrink. I didn't clean off any of the tops or anything like that. Whatever was on there was on there. Alright, this test is only a representation of what a pack would look like if one of the cells shorted out and the fuse popped. That's pretty much it, just doing what the fuse is designed to do. I've got some simulated bus bars right on this side, and I'm basically going to go on the underneath side and short it out. And I'll probably do this from a few different angles with and without light. So here we go. Contact. Definitely stinky. I'm gonna turn on my exhaust fan. And I'm going to, I guess, upgrade from 3 volts to 5 volts just so we can get it to pop a little bit faster. That was on the 3.3 volt rail, so give me 1 second. Alright, I've got 5 volts hooked up this time, and we'll see if we can pop it a little faster. We're probably going a little slower because I've got a longer wire to short it out, so we're probably losing quite a bit of voltage. Contact. That one popped it a little bit faster, so that's much better. That's more of like a simulation of what it'll do. I think if the CID is actually popped, some of these it won't actually work. So the ones that didn't pop, the actual CID I believe is popped, so it's not I was not expecting that. So there you go. All right, so the next thing that was requested was, how do you replace a bad cell in the center? Well, I would say there's 2 or 3 different options. Option number 1, if you're going for looks, is just to rip it all off and replace the cell and then replace the entire strip. I know that would suck on a bigger pack. I guess if you had a little pack like this, it wouldn't be no big deal, but just imagine this being like an 80 cell or 100 cell pack or even bigger. Yeah, I mean, that's a lot of money to just replace one cell. So the other 2 options I could think of is maybe use some scissors and just cut out a strip and then replace your cell and then replace that entire strip, but making it just a little bit wider. Another option would be to possibly use a Dremel tool and cut out a square and then replace your cell, but I think that's asking for quite a bit of trouble to do that. So I think the best option for something like this would be to just cut out this 4 parallel strip right here, and then when you cut off a new strip, you know, just make it as wide as you can get and then spot weld it in a bunch of places back in. That's really the only thing I can come up with. I mean, we could try that real quick. I'm gonna try to go in as far as I can, so that way when I cut the strip out of here, I can go wider and I'll have something to spot weld to. Whether that works or not, I don't know. Oh, I was like, why isn't it coming off? I still got a couple fuses attached there. Alright, so that's the rough idea. I didn't mess up these fuses, you know, from it going up and down, because you do get quite a bit of play. Alright, so then you would pop out your cell. So what I'm going to do is I'm going to cut right along this edge of these cells right here, and then the same thing on this one, so I can get as much material as I can. Alright, so that's pretty much what we're working with right here, and the idea would be to just replace it like so and spot weld along the edges here. That's the only thing I can come up with. And I'm maybe gonna avoid right where the other cell fuse is at. I probably didn't need to go that close to the edge over there either. I could have gone down here in the center. I don't know, what do you guys think? Is there any other options that one could try? Could this work in a pinch? Yeah, I think so. Could I have done a little bit better spot welding the strip to the other strips? Yeah, definitely. Alright, there you go. All tests complete. Hopefully it wasn't boring or anything like that. Do you guys think that those tests were good enough? Do you think some of them sucked and I should have done it better? If you did, please don't hesitate to call me out in the comment section, because, you know, if I can improve something, then I'm cool with that too. Just don't be an asshole about it. Just kidding, you can be an asshole. I don't know, I mean, I thought they worked pretty damn good. If I could make the fuse tester, you know, smoother in some of the transitions, I mean, I could buy like a real power supply, but I'm not gonna do that. I'm just gonna use this. It works. I thought this test actually worked out pretty good. So what I think I'm gonna do is redo not all of my old testing videos, but I am going to redo all the glass fuses. Actually, Keith, he's gonna send me out a bunch of his fuses so we can redo all those glass fuse videos. And I'm gonna do it all in one. Probably very similar to this one right here. It'll be boring as hell, but hopefully you guys will watch it and we can all learn something. And I'm not gonna tell you guys whether you should or shouldn't use fuses or fused nickel strip. That's gonna be something for you to decide. So whenever building your packs, make sure you build accordingly and stay safe. All right, that's pretty much all I got. If you guys have anything to say, any improvements or something I did completely wrong, put it down in the comment section. If you plan on purchasing anything from Battery Hookup, please click on the affiliate links below, because I do get a little kickback for that. And also be sure to use the discount code BOOM. Don't forget to like, comment, and subscribe, and I'll see you on the next one. All right, I'm Average Joe. If you haven't been to my channel, then I don't know what you've been doing. Boom! And I'm also gonna throw the thermal camel. This still stinks. This still stinks. Well, that's a mouthful. Boom! We're just gonna put it on the old fuse test. And that's a big shout out to Keith over at 18650 Heat Shrink and all the stuff. Super, super fast and packed excellently. I almost said excellency. Boom! So get down. So sit down, get comfortable, grab your favorite cat, and let's get to it. I feel like I got a hair stuck to my face. which I probably did actually. I did. Sounds kind of gay. Alrighty. Alrighty, Roo. Am I recording? Yes, I am. Big shout out to Kieth for sending out his package super fast.